Now today we will do some more problems related to network theory, Maxwell's loop analysis. In Maxwell's loop analysis, already I told you in previous classes how to find the loop current. If there are different loops, suppose if the loop consists of 3 loops, if the network consists of 3 loops, then we will find the 3 currents I1, I2 and I3. And this type of problem has been asked in GATE examination, also IAS exam and also competitive examinations. So, if this type of problem, how will you solve, how will you find the current here in this problem or in this numericals, find the current I in the circuit. This is a branch AB let, what amount of current flow through this branch. So, first of all, if we modify the circuit, there is a current source, remember. So, there is a current source here, this one 1 ampere current source. First of all, we have to redraw the circuit. Redraw the circuit means, so we have to convert it, this network. So, this is your 2 volt and 1 ohm. First of all, we will convert it into the current source. If there is a voltage source, then we can convert it into current source. If there is, how to convert the current source from voltage source. So, I equal to V by R, 2 by 1, that is 2. So, this current is nothing but the 2 ampere. If there is a current source, must be the resistance must be parallel, and this is 1 ohm here, 1 ohm. Then and here also this is 1 ohm. This is nothing but the current source 1 ampere. Okay. From this one, so we can convert it this to this. So, this is your what, 2 ampere and this is your 1 ampere, both are incoming current, and this will be how much? This will be 2 ampere plus 1 ampere, that is your 3 ampere current source. This is your 3 ampere. Then there is an 1 ohm, and then what? Again you converted into the voltage source. So, V equal to I into R, that is your 3 into 1, that is your 3 volt, and is your 1 ohm. So, instead of this we can put this one 3 volt 1 ohm resistor. So, instead of this we will put, that is your 3 volt, and so if we redraw the circuit, the circuit will be like this. This is your 3 volt and this is your 1 ohm, 3 volt and this is your 1 ohm. Then this is your 2 ohm, this is your 1 ohm, this is your 1 ohm, this resultant circuit is like this. So, here that is your 2 ohm, your 1 ohm. Okay. The circuit can be changed into this one, and you will find 3 loop, loop 1, loop 2 and a loop 3, and here the current through the loop 1 is I1, here I1, this is your I2 and this is your I3. If the current source is like this, you can modify the circuit into this one, that is your, and you will find again 3 loops, loop 1, loop 2 and loop 3. Again we apply the Maxwell's loop analysis. So, if there is a 3 loop, then that is your resistance matrix into current matrix equal to voltage matrix. So what we will do next? From this circuit we will find the current I1, I2 and I3. How to find the I1, I2, I3? In loop analysis or Maxwell's loop analysis, already you know the resistance matrix into current matrix is your voltage matrix. So here, since it is a three loop, so there is your 3 into 3 resistance matrix. Resistance matrix R, first is your R11, R12, R13, R21, R22, R23, R31, R32, R33. First is your loop 1, R11, sum of the resistance formed by the loop 1. How many number of resistance in the loop 1? 3 resistance, 1 plus 2 plus 1, that is your 1 plus 2 plus 1, 2 plus 1, 3 plus 1, 4, R11 that is your 4 ohm, R11 that is 4 ohm. Then R12, already I told you resistance matrix R11, R12, R13, R21, R22, R23, R31, R32, R33. This is your resistance matrix. Okay. So here R11, the sum of the resistance formed by the loop 1, that is your 1 plus 2, 3 plus 1, 4, this is your 4. R12, the resistance common between 1 and 2. In 1 and 2, this resistance is common, 2 ohm resistor, and put the minus sign, that is your minus 2. R12. Then R13, the resistance common between 1 and 3. 1 and 3 common, that is your 1 ohm. So put the minus sign, minus 1. Okay. Then come to R21. 1 to 2 1 is same. 1 2 2 1 same 2 ohm resistance. Put the minus sign, minus 2. Then R22. R22 is the sum of the resistance formed by the loop 2. In the loop 2, how many number of resistance here? 1 plus 2 plus 2. 2 2 4 plus 1 5. That is your 5. In self loop, R22, R11, R33. R11 sum of the resistance formed by the loop 1. R22 sum of the resistance formed by the loop 2. And R33 sum of the resistance formed by the loop 3. So here R22 sum of the resistance formed by the loop 2. 2 plus 2 4 plus 1 5. Then R23 resistance common between 2 and 3. 2 and 3 common is what? This 2 ohm resistor, put the minus sign. This is your minus 2. Then come to R31. 31 means 1 3. 1 ohm resistor is common, that is the put the minus sign, minus 1. Similarly R32, the common between 2 and 3, that is your 2, that is your minus 2. Then R33, the sum of the resistance formed by the loop 3, 1 plus 2 plus 1, that is your 4 ohm. This is your 4 ohm. This is your resistance matrix. Here into current matrix, that is unknown values I1, I2 and I3. The current we are going to calculate, that is your I1, I2, I3. So this is your unknown values I1, I2, I3. Using Cramer's rule, we can find out the value of I1, I2 and I3. The resistance matrix into current matrix is your voltage matrix V. First of all, this is your V1, V2 and V3. This is your, this column is nothing, matrix is nothing but V1, V2 and V3. Since it is your 3 into 3 matrix, resistance matrix into current matrix, similarly voltage equal to, you will find the 3 net voltage. The net voltage in the loop 1, net voltage in the loop 2, net voltage in the loop 3. In net voltage in the loop 1, already I told you net voltage in the loop 1. If there is a voltage source is there, if there is a minus terminal and plus terminal, put the symbol minus to plus is always plus. This is a thumb rule. So if there is a voltage source, put the symbol here, minus to plus is plus, the direction is like this. If this current direction is same as this voltage direction, that will be plus. So in this loop, means loop 1, you will find only one voltage source, that is your 3 volt. If this current source, this is clockwise, already I have assumed the in 3 loop there are 3 in the clock, that is your what? The current flowing in clockwise direction. So that's why this is on clockwise, the current direction is same as the voltage direction. In the I1 direction of current I1 is same as this voltage source, the net voltage that will be plus. In place of V1 I can write only 3 volt because the direction of current I1 is same as this voltage direction 3 volt, that is your 3 volt. Then come to second loop, loop 2, there is a voltage source here, minus to plus is always plus, put this symbol is like this. Here the direction of current I2 is opposite to this voltage direction. Look at this, this loop 2, the current direction I2 clockwise is opposite to this voltage direction. If it is opposite, then put the minus sign. That will be, this voltage source is, this is nothing but your 2 volt here, 2 volt, this is your 2 volt. So in place of net voltage V2 I can write minus 2. Why I am putting minus 2? Because my current direction I2 is opposite to this voltage direction, that's why this will be minus sign, minus 2. Then come to loop 3, then V3, net voltage in the loop 3 or V3. This is your loop 3. Here the current direction is same as the voltage direction. Here the current I3, direction of current I3 is same as the voltage direction. Since the current direction and voltage direction is same, you can put here only 2 plus 2, this one. Once you construct this matrix, resistance matrix into current matrix, that is your voltage matrix, using Cramer's rule, you will find out the value of I1, I2 and I3. So how will you find I1, I2, I3? By using Cramer's rule. So first of all, find out this matrix value. This is your resistance matrix. So as usual method, that is your what? R. Resistance matrix is how much? That is your 4 whole into, that is your multiply this into this, multiply this into this. First this 5 into 4 20 minus minus plus, that is your 4, 20 minus 4. Then middle, that is your minus, if minus plus 2, that is your what? If you minus 2 means, if you close this one, you will find this. So that's a 4 into minus 2, that is your minus 8. Again minus plus minus 1 into 2, 2. Then come to third, that is your minus 1. That is what? If you close this one, then you will find this one, minus 2 into minus 2, that is your plus 4. Then minus plus 5, you will find this one. Okay. So then what you will do? That is your 4, 20 minus 4, that is your 16. 4 into 16. Then plus minus 8 minus 2 minus 10. 2 into minus 10. Then minus 1 into 4 plus 5, that is 9. 9 into minus 1 minus 9, and this is your minus 9. The value becomes what? 16 into 4, that is your 64. That is your 2 into minus 10 minus 20. Then minus 9, that is your 64 minus 29. The value becomes what? That is your 35. That is your 35. The value of R value is your 35. The value of R is 35. The resistance matrix value R equal to your 35. Then how to find out the current I1 using Cramer's rule? I1 value is how much? I1 is nothing but what? Using this equation, if you close this first column, when you are going to calculate I1, simply close the first column of resistance matrix 1. Then come to this one. Using these three resistance matrix and the voltage matrix, that is you will find 4 columns, first column, second column, third column and fourth column. When you are going to calculate I1 means first column, simply close the first column. In the right side, first of all you consider this one, that is your 3 minus 2 2. Then come to here, that is your except first column, that is your minus 2, then 5, then minus 2, then minus 1, minus 2, then 4. This divided by what? That is your resistance matrix, that is your 35, and the value becomes what? That is your, the value becomes what? I1 equal to what? That is similarly value of this what? 3 into 5 into 4, 20 minus 4, that is your 3 into 20 minus 4. Then minus plus 2. If you close this one, you will get this 4 into minus 2 minus 8 minus plus 4. Then minus 1, that is your what? Minus 2 into minus 2, that is your minus 4. Minus 2 into minus 2, that is your plus 4. plus 4 minus 10. Are you clear or not? That is your, this becomes what? Divided by I1 equal to this divided by what? That is your 35. So that will be equal to what? That is 3. 20 minus 4, that is your 16. 3 into 16. Then minus 8 plus 4, that is your minus 4 into 2. Minus 8. Then minus 4 minus 10, minus 6. Minus 6 minus 1, that is your plus 6. That is your 48 minus 2. It will becomes what? That is your 46. That is your 46. 46 divided by 35. I1 equal to 46 divided by 35. Divided by 35. Divided by 35. Divided by 35. So I1 value is your 46 divided by 35. That is your I1 equal to 46 divided by 35. Similarly, we will find the value of I2. How to find the I2? Simply you close the second column. To find I2, what we will do? To find I2, which column you will take? Simply close the second column. In left side you will find the first column. 4, that is your minus 2, then minus 1. Then what will do? Again take 3, minus 2, 2. Then you will take minus 1, minus 2, that is your 4. Okay. This divided by 35. Then you will find what you will do? Find the value of this. That is your 4. I2 equal to, this is nothing but I2. So I2 equal to this one, or the I2 equal to that is your 4 into this minus this into this. 4 into minus 2, that is your minus 8. Minus plus, that is your 4. That is your 4 into this one. 4 into, that is your minus 8, minus plus 4. Again middle, that is your minus 3. If you close this one, you will get what? 4 into minus 2, that is your minus 8. Minus 1 in minus 3 minus becomes minus, that is your 2. Then minus 1 into 2 into minus 2, that is your minus 4. Again minus, that is your minus 2. So divided by this, divided by 35. Okay. If you solve this, simplified this one, minus 8 plus 4, that is your minus 4. Minus 4 into 4, that is your minus 16. Then minus 8 minus 2, that is your minus 10. Minus 10 into minus 3, that is your plus 30. That is your again minus 4 minus 2 minus 6. Minus 6 into minus 1, that is your plus 6. This divided by 35. The value becomes what? 36 minus 16. That is your only 36 minus 16. That is your 20. That is your 20 by 35. The value of I2 equal to 20 by 35 ampere. So I2 equal to 20 by 35. 20 by 35 ampere. Then find out the value of I3. When we are going to find out the value of I3, what will do? I3. When you are going to calculate the value of I3 using Cramer's rule, that means I3 means what? Simply you do not consider value of the column 3. That is your, if you close this one, in left side you will find the 2 column. So I3 equal to first you take the 2 columns here, that is your 4 minus 2 minus 1, again minus 2, 5, then minus 2, then 3 minus 2, then 2. This divided by 35. Are you getting or not? Then if you solve this one, I3 equal to, that is your 4 whole into this minus this into this, 4 into, that is your 5 into 2, 10, minus minus plus minus minus, that is 4, then minus minus plus, 2 whole into, if you close this one, 2 into minus 2, that is your minus 4, minus minus plus minus minus, that is your 2, again plus 3 whole into, that is your 2, minus 2 into minus 2, 4, plus minus minus plus 5, this divided by 35, the value becomes what? That is your 4, 10 minus 4, that is your 6 into 4, 24. So that is your 24. So I3 equal to 24 minus 4 minus 2, that is minus 6 into 2, minus 12, 4 plus 5, 9, 9 into 3, 27, plus 27, divided by 35, that will be what? 24 minus 12, 12, 12 plus 2, 14, that is your 14 by 35 ampere. Are you getting or not? So I3 equal to 14 by 35 ampere. Okay, now we are going to calculate the value of I. The question asked, what is the current flow through this branch AB? Look at this here. This is your I1. The current through this branch loop is your I2, and this is also what? That is your I3. What amount of current flow through this branch I? I is nothing but what? If you look at this one, this is your I2, this is your I2, and this is your I3. If you applying Kirchhoff's current law at this point, here incoming current I, here also incoming current, here this is your outgoing current. If you apply Kirchhoff's current law at this point B, if you apply KCL, apply Kirchhoff's current law at which point? B, at point B, what you will find? That is your incoming current equal to outgoing current. This is your incoming current I plus I2 equal to I3. I plus I2 equal to I3. Or I is how much? The value of I equal to I3 minus I2. I3 minus I2. That means indirectly the question asked to find out the value of I3 minus I2. Here the I value is nothing but that is your I3 minus I2. I3 minus I2. So I3 value is how much? 14 by 35 ampere. Here I3 value is your 14 by 35 minus I2 value is how much? 20 by 35. 20 by 35. That value is how much? 14 by 35 minus 20 by 35. That is your minus 6 by 35. Minus 6 by 35 ampere. Minus 6 by 35 is nothing but what? 6 by 35. 6 by 35. 6 by 35. 6 divided by 35. The value is your 0.1714, and this is your minus 0.1714 ampere. That is the current direction. I have here assumed the current direction is flow from A to B, but actually the direction of current flow from B to A. The direction of minus sign indicate that will be your current direction is opposite to the assumed current direction. Here the current I is your from A to B, but our calculation we got I equal to minus 0.1714 ampere. This indicate that the negative sign indicate that the current flow from B to A, not A to B. The value of I, current I equal to net current I equal to your 0.1714 ampere. And here you can write, if you write the positive number I equal to, if you write I equal to 0.1714, and you can write that is your B to A. If you put the minus sign, that means what? A to B. If you write B to A, that indicate that this is positive, here this is negative. This negative sign indicate that your direction of the current flow from B to A, not A to B. Thank you. Next class we will do more and more number of problems which will helpful for competitive engineering examination, public sector examination, and GATE, also IAS examination. Thank you. कितने मिनट वाला